My dear students, in the previous video, I introduced the section formula for finding the position vector of a point which divides a line segment in the ratio m:10 internally. The position vector of the point R is given by R vector is md vector plus na vector by m plus n we have seen. So internal division we have seen in the previous video. In this video also I am going to introduce the section formula for external division. Section formula for external division, that is the position vector of the point R which divides the line segment joining the point P and Q in the ratio m:10 externally. This is the point R. O is the origin. This is the point P. PR is m times, and this is the point Q. The position of the point Q is OQ, that is given by B vector, and this is the position vector of P is OP vector is given by A vector, and the position vector of R vector is OR is R vector, that is small r vector. So PR, this is m times, and QR is n times. P, the point R divides the line segment PQ externally. The R is in the external division of the line PQ in the ratio m:10. PR is m times and QR is n ratio. PR by QR. So R is the point. Now we have to find out the position of the R which divides the line segment PQ externally in the ratio m:10. So the point R divides the line segment PQ externally in the ratio m:10. If it is the case, we have to find out what is the position vector of the point R. We have to find out the position vector of R. The position vector of R, we have to find out. It is we taken that position vector of R is small r vector. We have to find out that R vector. Position vector of P is OP is A vector. The position vector of P is A vector, and the position vector of Q is B vector, you know. That is the position vectors of P and Q are A and B respectively. OP is A vector and OQ is B vector. Now we know that R divides PQ externally in the ratio m:10. Therefore, PR by QR equal to PR is m times of n, QR is n, PR is m. Now m into QR is equal to n into PR. You consider this as vector m into OQ. M into QR. M into QR cross multiplication. M into QR vector equal to n into PR vector. So you know that m into QR is OR minus OQ. OR minus OQ, which is equal to n into PR is also OR minus OP. The position of OP is A and position of OQ is B and the position of OR is R. So this is m into r vector minus oq is b vector equal to m into over is r vector minus op is a vector. Now multiplication mr vector minus m into a vector equal to left hand side is m into r vector minus m. This is m. I'm sorry. N into PR is over minus OP. Over is R. OP vector is a vector. So N into R vector minus N into a vector. Right hand side, left hand side is M into R vector. Now this is M into B vector. Okay? You bring this NR to the left hand side, already you have MR here. If you bring this NR, left hand side is become minus NR. If you bring this minus MB to the right hand side, it is plus MB. Already minus NA is there. Now MR minus NR, you can take R vector as common. You will get R vector as common vector. You get M minus N on the left hand side. Equal to right hand side is MB vector minus NA vector. MB vector minus NA vector. Now we want R vector, therefore R vector is MB vector minus NA vector by M minus N. So this is the position vector of the point R, where the vector point R divides the line segment PQ externally in the ratio distance. Whereas in the internal division, R vector is, if the point R divides internally, you get the position vector is MB plus NA by M plus N. This is we have derived in the previous video. It is internal division. This is internal division. This is external division. So if a point R divides PQ internally, the position vector is MB plus NA by M plus N. If the same point R divides the line PQ externally in the ratio M is to N, the position vector of R is MB minus NA by M is to N. The sign of the position vector will be changed. That's all. MB minus N. So that's all about the internal and external division of the position vector of the given point. Using this idea, we are going to solve one problem in the textbook given. Find the position vector of the point R, which divides the line segment P, line joining the points P and Q, in the ratio 2:1 internally or externally. That is the problem. So the problem is, find the position vector of R. PV means position vector. Position vector of the point R, which divides the lines, which divides the line joining the points, P. It divides the line joining the points P, 1, 2, minus 1, and Q, minus I plus J vector, point, the point is minus 1, 1, 1. So the point given P is 1, 2, minus 1, and the point Q is minus 1, 1, 1. See, find the position vector of R which divides the line joining the points P and Q in the ratio 2:1. in the ratio 2:1, one internally or externally. In both the cases we have to find out the same problem. We have to find out the both ratios, internal ratio and external ratio for this point R, which divides the line PQ. See, you know that this is a point P and this is a point Q, and R divides the line PQ internally in the ratio 2:1. First, if R divides PQ internally in the ratio 2:1, then his position vector OR vector equal to in the ratio 2:1, then the position vector of R equal to R vector, that is equal to MB plus NA by M plus N. This is the internal vector division formula. If the point divides the line internally in the ratio M is 10, so MB plus NA by M plus N is the required point. A vector is position vector of the point P. So this is A vector. What is A vector? Position vector of the point OP is A vector, that is I vector plus 2j vector minus k vector. I plus 2j minus k, this is position vector of the point P is A, and position vector of the point B is Q is B, that is minus I plus j plus k. So substituting the M is 2 and N is 1. That you just apply these values in the result, you will get the position vector of the point R equal to M is 2 into B vector. B vector is minus I plus j plus k plus N is 1 into plus MB plus N is 1 into A vector is I plus 2j minus k by M plus 1 and 2 plus 1, that is equal to minus 2i, minus 2i vector plus 1 into I minus 2i plus I vector. Similarly, plus 2j plus 2j. Combining the vectors, plus 2k, already here plus 1 into minus minus k, 1 into minus k by 2 plus 1 is 3. So you have 2 minus 1 is minus I plus 4j, 2 plus 2 4j, 2 minus 1 plus k by 3. That's all. Okay. You divide each and every vector by 3. This is minus 1 by 3i plus 4 by 3j plus 1 by 3k. Like that you convert this result. Minus 1 by 3i plus 4 by 3j plus 1 by 3k is the position vector of the point R, which divides the line PQ internally in the ratio M is 2:1. Similarly, if R divides, this is first result. Second one, if R, the point R divides PQ externally, just second one, externally in the ratio 2:1, then the position vector of R is R equal to MB. Just you convert the plus sign into minus sign, that's all. MB minus NA by M minus. The same application, the plus sign only change, you will get M into A vector minus N into A vector by M minus N is 2 minus 1. Similarly, you get minus 2i, here minus j. So here just you convert that. In this case, this is minus 2i and plus into minus I. Minus 2j vector, here plus into minus 2j vector, plus into minus, again plus 2k, minus into minus plus k, divided by 2 minus 1 is 1. So 2i minus n is minus 3i, minus 2 minus I, minus 4j, this is plus 2j, this is minus 2j. Now j becomes 0, 2j plus 2j minus 2j 0, so j becomes 0 and plus 2k, minus or minus plus k, you will get plus 3k. So minus 3 divided by 1 is the same term, divided by 1 you need not write. So 3i minus 3i plus 3k is the position vector of the point R if it divides the line PQ externally in the ratio 2:1. Okay, that's all about the problem. Next, another problem. Suppose if the point R divides, so for external, the diagram is just changed. For this case, external division, R will be here, Q will be here. So PR, this is PR, and QR. PR is 2 times and QR is 1 time. This is 2:2. External division, PR by QR. Okay. See, next, if the point R divides PQ equally, or otherwise it is a midpoint, what is the case? That is our condition. It's a note for that at second formula. If the point R divides the line PQ equally, or R is the midpoint of the line PQ, what is the case of the position vector of the point R? In this case, if the point R is the midpoint of the given line segment, what would be the position vector? We will see. See, this is Q and this is the point P, exactly midpoint. R is exactly the midpoint. R is the, note, if R is the midpoint of the line segment PQ, if R is the midpoint of PQ, that means then the ratio is M is to M. M and N are equal. M is to N, that means both are same, 1 and 3. So 1 is to 1 it will become. If it is the midpoint, M and N are equal, therefore 1 is to 1. If R is the midpoint of PQ, then R divides PQ in the ratio 1 is to 1. M and N are equal. So if it is the case midpoint, the position vector of OP is A vector, and position vector of OQ B vector. So position vector of OR is R vector. So midpoint is R vector equal to MB plus NA by M plus N. M and N are equal and that are 1 So 1 into B plus 1 into A by 1 plus 1. So if it is the midpoint, then R vector equal to MB 1B plus 1A by 1 plus 1, that is B plus A by 1 plus 1 is 2, or otherwise you can simply write as A plus B by 2. If R divides PQ equally, or R is the midpoint of the line PQ, then the position vector of R is A plus B by 2. Position vector of P plus position vector of Q divided by 2. It is a midpoint case. So if a line segment, if a point divides the line segment in the ratio 1 is to 1, or otherwise it is the midpoint of the line PQ, then the position vector of the point R is A plus B by 2. OP plus OQ by 2. For that we have one problem. Find the midpoint. Find the position vector of the midpoint. Find the position vector of the midpoint or midpoint. Find the position vector of the midpoint or which. Find the position of the midpoint or of the line. Midpoint of the line, segment of the line joining P. The point P is 2, 3, 4. And Q is 4, 1, minus 2. If these two are P and Q are the two endpoints, P, what is that? 2, 3, 4. Q, 4, 1, minus 2. We have to find out the midpoint R, position vector of the midpoint R. We divide the line 1:1. You know that this is the position vector of OP is A vector. A vector is 2i plus 3j plus 4k. B vector, OQ is B vector. B vector is from this point you can write 4i. This is 2i plus 3j plus 4k. Here B vector is 4i plus j vector minus 2k vector. This is B vector. We want R vector. Question of R is A plus B by 2. Formula is A plus B by 2. A vector plus B vector by 2. What is A vector? 2i plus 3j plus 4k. The B vector is 4i plus j minus 2k vector by formula it is 2, that is 2i plus 4i is 6i. 3j plus j is 4j and 4 minus 2k is plus 2k by 2. So each and every term if you divide by 2 you get 3i plus 2j plus k. So this is the position vector of the point, midpoint of the line joining the point P and Q. Midpoint R vector is 3i plus 2j plus k, or simply you can say P plus Q, 2 plus 4. See, 2, 3, 4 plus 4, 1 minus 2. Simply you just write by 2. This is nothing but simple idea. 6 plus 1. 6 comma 3 plus 1 4 comma 4 minus 2 2 by 2. So that is equal to 3 by 2, 6 by 2 3i plus 4 2 4 by 2 2j 2 by 2 plus k. You simply solve like this one. Point wise you can add and find the midpoint and then you will write the simple idea. Ijk. Okay. So anyhow, the midpoint is nothing but the position vector of the first point plus position vector of the second point divided by 2. Midpoints. That's all about the position vectors. Next, one more problem I am going to solve. Find the area of the triangle if the three vertices or the position vectors of the three vertices are given. That's our next problem. Show that the 3 points form a right angle triangle. That's our problem. If the position vector of the 3 points are given for a triangle and you have to prove that the triangle should be a right angle triangle. The position vectors of the 3 given vertices of a triangle are given. That's the problem you see. Third one. The position vectors of the vertices of a triangle The position vectors of the edges of the triangle are given as A, the vector J is 3, minus 4, minus 4. And B, the point B, another vector B is 2, minus 1, 1. And the vector C is 1, minus 3, minus 5. If these 3 points form 3 vertices of a triangle, we have to show that the triangle is the right angle triangle. You know the right angle triangle means it by Pythagoras theorem, square of the adjacent sides equal to hypotenuse square. That we have to prove. So the position vector of the one vector OA vector is 3i minus 4j minus 4k, and OB vector is 2i minus j plus k. 3i minus 4j minus 4k, 2i minus j plus k, and OC vector, position vector of the triangle OC vector is I minus 3j minus 5k. From this you have to find out the 3 sides first. The side AB, the triangle, the side of the triangle, the side AB equal to, AB vector equal to OB minus OA. What is OB? 3i minus 4j minus 4k. This is OB. Sorry, this is OA. OB minus OA. OB is here. OB is 2i minus j plus k. 2i minus j plus k. OB minus OA. Minus OA is minus 3i. Minus of minus plus 4j. Minus of minus plus 4k. On changing the sign, it is minus OA is minus, we will multiply OA vector by minus sign. That is minus 3i plus 4j plus 4k. Now AB is 2 minus 3i is minus I. 4 plus j plus 4 minus j is plus 3j, and 4k plus k is 5k. 3j, 4k plus 1k is 5k. This is the vector AB. So to find out the magnitude of the vector, the length of the side AB is mod of AB, you have to determine. What is mod of AB? Modulus vector of the vector AB is distance AB. Mod of AB is root of minus 1 square plus 3 square plus 5 square. On squaring, minus 1 becomes plus 1. 1 plus 9 plus 25. So 25 plus 10, root of 35. This is AB. Distance AB we have, side AB we have determined. Similarly, BC vector. BC vector is OC vector minus OB vector. You know OC vector. I vector minus 3j vector minus 5k vector. OC minus OB. You multiply OB vector by minus. OB vector by minus. Minus 2i. Minus into plus, minus plus j and minus k. Here you get minus 2i plus I is minus I vector. Minus 3 to 3j plus 2j is minus 2j. Minus 5 minus 1 is minus 6k. Okay. Now this is, what is it? 36. BC. This is BC vector. We have to find out the modulus distance BC. BC vector, magnitude of BC vector is root of 1 square plus 2 square plus 6 square. Even though the minus sign becomes plus 1 square, on squaring is 2 square plus 6 square. Minus 2i plus I minus I plus j minus 2j minus 2, 3j minus 2j, and minus 5 minus 1 is minus 50. Okay, 36. 1 plus 4 plus 36, 40, 41. So square root of 41. This is your BC. Distance BC. Similarly, we have find out another side AC. AB, BC you have determined. Next, we have to find out the side AC. Here also AC vector equal to this is BC and this is AB. Now I am going to find out AC. AC vector is the third side OC minus OA, OC I minus 3J minus 5K minus OA, multiply OA by minus 3I minus into minus plus 4J minus into minus plus 4K. So this is equal to 3I minus I is minus 2I, 4J plus minus 3J is plus J, minus 5 plus 4 is minus K. So this is AC vector. Now modulus of AC vector is root of 2 square plus 1 square plus 1 square, that is equal to root of 4 plus 1 plus 1. Therefore this is equal to root 6. This is your distance AC. So after finding the three sides, AB square plus AC square equal to BC square. That's our Pythagoras theorem. Thereby it represents the right angle triangle. Because the sum of the squares of the adjacent side equal to the square of the hypotenuse we have. From these three sides, what is AB square? AB square is 35. AB square is 35. Root 35 square is 35. AC square 6. BC square 41. So AB square plus AC square equal to BC square we have. That is 35 plus 6 equal to 41 derived. So AB square plus AC square equal to BC square. Therefore ABC is a right angle triangle. BC is the hypotenuse. Therefore BC is the hypotenuse. That means A is the right angle. A. BC is the hypotenuse entire side. This is root 6. What is that? 41. BC is root 41. AC root 6. AB root 35. So angle A right angle. Therefore AB square plus AC square equal to BC square is a right angle triangle. That's all about the problem. Therefore A is a right angle. So ABC represents a right angle triangle because sum of the squares of the adjacent is equal to square of the hypotenuse. Therefore ABC represents a right angled triangle. Right angle at A. That's all about the problem. Thereby I conclude this video and we will continue the next topic in the next video. Thank you.